Hello and welcome to TN Academy. Today we are doing question 5, where we're given the graph of y is equal to x divided by x squared plus 2, where x is always greater than or equal to 0. We're also given a graphical or pictorial representation of this, where r is the area under the curve between the curve and the x-axis, and its value is ln 3. So r is equal to ln 3. Okay, and we are asked to find the value at point C. So the way we're going to solve this question is we are going to integrate our function y and evaluate for the lower and upper limits so that we can then solve for C. So to start, we can write out our integral, where we know that the integral will be equal to the area under the curve, which is also equal to ln 3. And when we write this out, we have the upper limit of c and the lower limit of 0, and we're evaluating the function y, which is x divided by x squared plus 2 dx. Now to integrate this, we will have to use substitution, where we can let u equal x squared plus 2. Then when we take the derivative of this, du over dx becomes 2x dx. Okay, and then when we rearrange to isolate for dx, we get that dx is equal to 1 over 2x dx. And we must note that our limits, our upper and lower limit, will also change. So when we evaluate, our upper limit u2 becomes c squared plus 2, and our lower limit u1 becomes 0 squared plus 2. So then when we rewrite our integral with our upper and lower limits changed and our substitution, we get the following, which is still equal to ln of 3, and we get 1 over 2 by 1 over u du. And since 1 over 2 is a constant, we can factor that out of our integral, and now we can actually evaluate this. And so to evaluate, we have to use the rule that the integral of 1 over u du is equal to ln u plus c. So we get the following, where ln 3 is still equal, ln 3 is equal to 1 over 2, and then the ln of u evaluated at both the upper and lower limit. And we know that when we're evaluating an integral for its upper and lower limit, we evaluate it first at its upper limit and subtract it by the same function by its lower limit. So our function becomes 1/2, and then ln u c squared plus 2 minus ln 2. And if we continue onward, we get, we multiply both sides by 2 so that we can simply evaluate for the lns of each function. And we can use the power rule and the quotient rule, to simplify our expression so that ln 3 on our left side can be raised to the power of 2, and so that ln of c squared plus 2 minus ln 2 can simply be turned into a fraction, so that we get ln of 9 is equal to ln c squared plus 2 divided by 2. And if we take the logarithm of both sides, we can simply evaluate for the value inside the expression, so that we get 9 is equal to c squared plus 2 divided by 2. And if we multiply both sides by 2, then we get 18 is equal to c squared plus 2, and subtract 2 from both sides, so we get c squared is equal to 16. And if we take the root of both sides, we get that c is equal to plus or minus 4. And since we are evaluating for a c that is greater than 0, then c cannot equal -4, and so we must conclude that c is equal to 4. And that is your answer for this question.